Hello, everyone, and welcome to today's session Machine Learning Basic Tools Introduction to Numpy. Previously, in the last session, we have discussed about the tools that is needed in machine learning, especially when you do different stuffs, different tasks. You need different kind of packages, and we have discussed those in the previous class, as we can see here. Today, the agenda for our session is to study this NumPy. Now, the first thing, what is NumPy? Let, let us start from here. What is it? Well, NumPy is a Python package, as you can see, Python package, or you can say library. But why? Why NumPy? Well, NumPy is used to tackle something called matrix. Now, I think you have heard of this term, matrix, in your 8th, ninth, or 10th grade. It is a mathematical term, math term, okay? And the sign goes like this, a third bracket. Seen that? I hope you guys are familiar with that. Matrix, okay? So this is matrix, and inside a matrix you have some elements, okay? Here I am placing 9 elements, and these are called entries. Entries, clear? This is called row, and this is called column. Okay, fine. So we are seeing what is matrix, but why matrix itself is used for? What is the functionality? Well, as you can see, the matrix is represented by a third bracket. Inside this, there are entries. So you can guess it is kind of like a container, right? Okay. So we use matrices for our easiness in case of mathematics. I'll give you an example. Like suppose this is A and this is B. You can do plus, minus, multiplication and division with this. Okay. Now if it is A1, A2, A3 and lots more, okay, you can do operations B2, B3, etc. Right. But you have to do this one by one. First of all this one, secondly this one, in third this one, and it goes on and on and on. But what is the benefit of using a matrix? The benefit of matrix is that if you have a matrix here and a matrix here, you can also do plus, minus, multiplication or division. It is also kind of a multiplication eventually. But you can do all of this, like there are entry A1, A2, 3, 4, 5, 6. Here you will have B1, B2, B3, B4, B5 and B6. You can do all of these tasks at a single time. At a time. At one go, you can do all of this. Okay, you can multiply A1 into B1, A2 into B2, and on and on and on within a one go. Whereas here you have to do all of this one by one. Firstly this one, secondly this one, in third this one, right? But in matrix you can do that in one shot. Clear? Okay, fine. So we have learned that matrices or matrices are used for mathematical purpose. It makes our maths easy. Okay? Now in programming, as I mentioned, to tackle matrix or matrices, you have Numpy. Right? Fine with that? So whatever we can do in math with matrix, we can do same thing using Numpy in coding. Okay? Coding matrix. Clear? Okay. Now, a question might arise in your mind that here we are seeing a third bracket. If you know Python, you have seen this same thing somewhere else. What is it? List. Okay, now you might be saying or having a question that what is this and what is this? What's the difference? First of all, let me clarify one thing. When we are dealing with these third brackets, we call them arrays. We call them array. Okay? And list is just called Python list. Fine? Fine. Now, the question, what's the difference between array and list? Why we should use array and why should we use list? Let us find out that. So here I have a table discussing the difference between the Python list and Numpy array. The first difference, as you can see here, is the data type and the structure. Here in Python list, let me zoom in a bit for you. Here in Python list, as you can see, in one list you can have multiple data types. Here you can see there's integers, there's float, there's a string, and there's a boolean. But in Numpy array, you can't have multiple data types. You can have only one or single data type. Okay, here as you can see, it is only integer. There's no other data types. Let me show you in coding. Let us go to our Jupyter notebook for today's session and let's see it practically. Okay, let's open a cell. Okay. As I have said, list can have integer, it can have float, sorry, 0.4, it can have, let's say, hello, and also a boolean, true. Now let's print it. It printed, right? Here's integer, there's float, there's string, there's also boolean. But what happens when you do the same thing in Numpy? Okay, before that, if you want to work with Numpy, you have to do something. It is called importing. If you have not installed Numpy in your environment, first of all do this, pip install Numpy. But if you have, you don't need to do this. As I already have, I'm going to proceed. Before you want to work with Numpy, you have to import it like this. Import Numpy, give an alias as np, run it. Okay, we are fine. So we have imported Numpy. Now we can use Numpy in our workbook, workspace, or notebook. It is giving us the signature allowance to use it. Okay. So let's have a Numpy array. Let me make a simple Numpy array. Okay. And print the same thing. I'm going to tell you how to use Numpy array a bit later. But first of all, let me clear the point. So in this cell, we have a Numpy array. But what do you think it will print? As I have mentioned earlier, that NumPy arrays are homogeneous. That is, you can have only one type of data in your NumPy array, whereas here you can see in the Python list you have all sorts of data types. Now let's print the NumPy array first. It printed everything, but did you see that there are something with in the left and right of 1? You see this? Yes. Now the one that you have placed here is integer, but the one here is a string. Similarly, 2.4 is a string, hello is string itself as we have inputted it, and true is also a string. So what is done here is called something called uh, upcasting. Okay, there's a term called upcasting. It means that if you add anything else, if you have multiple data types in your NumPy array, then it automatically converts it into one single data type. Okay, this is what is happening. It has converted everything into a string. If you had removed true, or let us not remove true, let us remove this one and let's print it. You see, everything turned into a float. One, there's a point beside the one. 2.4 is float itself. True, we know 0 means false and 1 means true. Now 1 has to be a float, that's why you can see a dot here. So basically what I'm trying to say is that NumPy array is homogeneous. No matter whatever you data type input it will do upcasting. If there's multiple data type, it will convert it into one data type. Okay, you can't have multiple data type, whereas in Python list you can have that. What are the other differences? Let's see those. It is slower. Why is it slower? It is having multiple data types. It stores elements as object and it stores different type of data, so it is slower. But here in NumPy it has fixed data types and it is also inbuilt efficient memory location. That's why it is faster. And what can we do with Python list? We can do appending, we can do slicing, we can do iterating. Similarly, in NumPy array we can do all of these things but something else. It is called broadcasting. Okay, another difference: more memory in Python list, less memory in NumPy array. Okay, and finally you can do nested list here if you want to create 3D 2D structures, and it is more space consuming and it is not as efficient as it is in NumPy array. Here you can very easily, without creating nested arrays or anything, there's a function array itself that can handle these multiple dimensions very easily. Okay, fine. And finally, what I have previously mentioned, broadcasting. Broadcasting. You can do that in NumPy, but you can't do that in Python list. We will cover this point later on. Fine. Okay. So now we are done with array versus Python list. We have discussed what is NumPy, what is it used for. We have discussed what is NumPy array and what is the difference between NumPy array and Python list. Okay, fine. So now the main thing, the coding part. What actually we are gonna do today? Let's see the agenda for today. First of all, importing NumPy. As I have already told you that if you want to use NumPy, you have to install it first in your machine. Pip install NumPy, If you have done that already, before you can use it, you have to import it, as we have done here. We will be discussing about NumPy arrays. First of all, we will be discussing how you can build NumPy arrays, create NumPy arrays in different ways. Okay, fine. We will be seeing different types of methods and attributes all related to NumPy. We will be seeing indexing and selection in NumPy and the broadcasting, as I have mentioned earlier. Also, we are going to see NumPy operations. Okay, so these are the agenda for today. Let's start one by one. First of all, let's again run the cell. We're going to import NumPy as NP. Okay, fine. Let me just check whether the recording is still on. Okay, fine. So let's build our array. Let's name it as ARR, that is array. Now the syntax is you have to do np.array. It is a function. Then whatever you like to make out of it, make an array out of it, you can input it here. Okay, so we're gonna run 1 2 3 4. Fine. Okay, let's see if our array is created or not. Yes, it is created. So this is the syntax. Okay, this is the syntax, np dot array. Keep in mind. Fine. Fine. Now you might be wondering that is it so easy? Okay, we know matrices have dimensions. Okay, can we create more 2D 3D stuffs? Yes, we can do that. First of all, let me show you how what does 2D and 3D mean. Basically, one dimension means there's just one line. Two dimensions means there's two line. Three dimension means there's three line. That is three dimensions. Okay, in 1D you're gonna only get a row of data. In 2D you're gonna get row and column of data. In 3D you're gonna get row, column, and something called depth. Okay, you're gonna get this one also in 3D. Now you might be wondering, okay, you're gonna do 3D, but can you do more? Yes, the answer is yes. You can do nth dimension, nth dimensions in NumPy. You can create as many dimensions as you want and build up matrices. Let's see. Let's see. First of all, we have created a 1D array since there's only one row. Now, if you want to know the dimensions, we can see the shape. Let's print it so it will be easier for us. Let's print the diamond shapes. Then also let's know the n dimension. And finally, let's print the data set itself. Let's run it again. Here you can see, if we scroll down, the shape is only 4, meaning there's only one dimension, that is row, and in the row there's 4 entries. Okay, there's only 4 entries. Here, this means the dimension ndim represents the dimension. As we can see, it has printed 1. That means it is 1D or one dimensional array. And finally, we have printed the array itself. Here it is printing. Now, for the fun part, to create a 2D array, can we do that? Let's see. Let's get down here and let's print it. Will it print? Will it print? Let's see. No. Why? Let me tell you why. Here what you have done is you have did 1 2 3 4 Again, you have done 1, 2, 3, 4. Will it print? Is it a matrix? No. What is it missing? It is missing the third bracket. It is missing the third bracket. So we have to give the third bracket. So let's give it then. This is the reason why we were getting the error. Let's give the third bracket. Okay, now it is fine. Proper. Let me space out a little bit. Okay. Okay, also this one. Fine, and let's print. Yeah. The shape is 2 by 4. There's 2 rows and 4 columns, as you can see very clearly. The dimension is 2. It is 2D. And the array itself is printed below. Now there's a hack. Like this, you can make as many dimensions as you want. But how to know the dimension? Obviously, you can check it with this one and dim, but also you have to keep in mind of this thing. You look at the leftmost or the rightmost part and see or count the number of third brackets are there. The number is equals to the dimensions of your array. Okay, here we have only 2 brackets, third brackets in the leftmost side, meaning it is a 2D array. Fine. Now the challenging part, can we build a 3D array? Before that, let me give you an idea what is actually a 3D array. So let us create a box. Okay, then let us copy it. Okay, again. Okay, we have 3 planes, right? We have 3 planes. Fine. This is plane number 1, this is plane number 2, and this is plane number 3. In 3D, what is happening? In 3D, the thing is, we are doing this. Let me grab this one first. Let me see. Okay, it is a bit difficult to grab. Still, let's see. Let's see, we can grab this one. Wait. Yeah. In 3D, the thing is, this plane is actually behind this plane. Okay, let me just erase all of this. Okay, let me handwrite this part, it will be better. This is plane number 1. The second plane is actually here. The second plane behind it, behind the first one, there's 2 layers. If you add a third dimension, it will be behind the second one, the third one. You see this? I hope you can understand. And the depth. This is the depth. This is depth number 1. The second one is depth number 2. The third one is depth number 3. But there's a catch. In Python, the counting starts from 0. So ultimately, if you count this, it will be depth number 0, depth number 1, and depth number 2. I hope I have cleared this dimension part. Okay. Again, I want to summarize. A line is 1D. If it is a plane, it is 2D. And if it is a cube like this, okay, there's row, column, and depth. This depth part, if it is present, then you're gonna call it a 3D. Fine. Okay, we can't imagine more than 3D as we are human being, but we can create a more than 3D arrays using Numpy. But we can't show it in graph, we can't show it or visualize it so simply or handwritten way. Okay, fine. Let's get back to our notebook and create a 3D array, shall we? Let's have the same data exactly as it is. Let's print it. Clear? Will it print? Will it print? Let me test you. Will it print? Let's see. No. What are we missing here again? The third bracket, the enclosure. So let's close this in third bracket. Now can you guess the dimensions? How can you guess it? The leftmost or rightmost total brackets. So here it is 3, so the dimension would be 3. That is, it is going to be a 3-dimensional array. Let's print it, and here you go. There's 2 rows, right? 2 rows, 4 columns. This is the depth. Okay, let me clear this one. Many of us make this mistake. In Numpy, when you mention the size, it is row by column. Okay, size, it is basically row by column, but when you add depth, it is row by column, but the depth is placed in front of the row. Clear? Okay, and if it is single, it will be just row. Fine. Okay then. So basically this 2 is meaning the row, this 4 is meaning the column, and this 2 is meaning the depth of our array. I hope I am clear. The dimension is 3. As I have mentioned, we have created a 3D array. How we can see that? The leftmost brackets. Okay, and this is our array. It has 2 layers, 2 depth. I hope we are clear. Fine. Okay, this is one way of creating a NumPy array using dot array method. We are going to go to our second way, that is using np.arrange. So let's write it, np.arrange. Now a really important tip, that is always use shift tab in Jupyter to see the docstring, the documentation of each function. Here you can see the doc, start, stop, and step. Okay, these are the parameters. Let us start from 1, let us finish at 10. Again, NumPy, the later value is excluded. So if we want to get up until 10, we have to write 11. Okay, and the step by default it is 1. But first of all, give us that and print it. Yeah, here you go. You have printed from 1 to 10, and the steps are 1. Okay, remember the endpoint is excluded, not included. Okay, it will print up until 10, not 11. Fine. Let us give another example of the same thing, shall we? Let's increase the steps to 2. Let's see what that prints. 1, 3, 5, 7, 9. It started from 1 and kept on stepping 2 until it reached 10. And here we get these 5 numbers, 1, 3, 5, 7, and 9. So this is the way you can use arrange method to build array. What else? We can use something called, we can use something called zeros. Let's make it. NP, okay, wait. Oh, yeah, let's create the array using something called zeros. Let's see the docstring. In zeros you have to use shape, so let's give a shape 3 by 3. Yeah, good. Let's print it. Okay, it is giving us an error. Maybe it should be in a tuple. Let's see if that works. Yes, it needed a tuple to be printed. Fine. Okay, so this is how you can use np zeros as well. Let's do another one, that is np.ones. np.ones, and let's see the doc string, the same shape. So for shape, let's see 3 by 3, and let's print it again. Here you go, here you go. Now you might be wondering, why is there a point after every number? We can also edit that. We can also edit that by using a parameter dtype integer, and boom, we have all the numbers or entries inside the array as integers. And as you can see, we have inputted 3 by 3 matrix, which is a 2D array. That's why we are having two brackets in the leftmost part of our array. Clear? Okay, what else? What else? Another one, using linspace. Now what is linspace? You can see here, return evenly spaced number over a specified interval. Okay, the numbers in this array will be evenly spaced no matter whatever you do. Let's see the doc string here. You have start, you have stop. Let's expand. You can include the endpoint or you can exclude the endpoint. Here by default it is true. So remember, here the endpoint is true, that's why it will be included, unlike the other ones that we have saw a bit earlier. If you put it to false, then it won't count it, it will exclude it. But by default it is true, so it will include it. Okay, let us see an example. We'll be starting from 1. We will be finishing at, let's say, 10. Okay, by default it has given us 50 values, and all the values are evenly spaced, equally spaced from 1 to 10. Clear? Now if we want lesser number, let's say we want 20 values. Let's see. Oh sorry, 10 values. So these are the 10 values. If you want 20, you can have 20. Yeah, all are evenly and perfectly spaced. Fine. Okay, this is the linspace method that you can use to create an array. And finally we have another thing, it is called that is identity matrix. Identity matrix, let me show you what is an identity matrix. See the doc string, it takes the dimension, only the dimension array. Okay, so let us create a 2D array first. Let us input 2 and print it. Okay, let's mention it. Yeah, so an identity matrix is the diagonal will be 1, and other than the diagonal all the other values will be 0. This is called an identity matrix. Fine, so we have inputted the dimension 2, that's why it is giving us two-dimensional matrix. If you inputted 1, let's see, I don't know if it is gonna print. Oh yeah, it is printed just 1. If we do 3, clear? Okay, so oh sorry, it is not dimensional, sorry, my mistake, it is row, it is row number. Okay, the you also have the uh, column here, but by default the row will be equal to the column. So if you just input 3, it will automatically assume the column is also 3. It is not dimension, my bad, it is the row. Okay, so you don't need to input the column here. If you just input the row, it will print, but both the values have to be same. Let me show you. Let's remove this one. Oh, guess what, it still prints. So you can mention the column here, but if you don't mention, the column will be equal to the row number that you give input here. Fine. Okay, so guys, these were the functions, built-in methods that we can use to create Numpy arrays, as you can see in the notebook. Fine, Now the next thing that we are going to study about NumPy is again creating array but using something called random module. Now in Python we use random module to work with random numbers. Similarly, we can do that. We can work with random module to create arrays. How? Let's see. Let's create an array np.random. Since we are using random module, now our first function is rand. What does it do? Shift tab, see the docstring here, random values in a given shape. Another most important thing is this one, from 0 up until 1 excluding 1. So it will be giving us random values from 0 but to 1 excluding 1. Okay, okay, fine, let's do that. Okay, what is there? Let's close. Yeah, so let us give a shape. It takes a shape, right? It takes a shape. Yeah, it takes a shape. Let us give 3 by 3 and see the output. Yeah, another thing to note here, in this function this shape is not in tuple. I have made this mistake quite a few times, so keep in mind it won't print. Okay, it will give an error. Here it is not a tuple. You just mention the row and column or whatever the dimension is and print it. No tuple. Okay, all the values will be random, and each time you refresh or rerun you will get different kinds of values, all ranging from 0 to 1 excluding 1. Fine. Okay, let's go to the next function, which is rand_n. It is same as before, but it uses something called standard distribution. Okay, it is called standard distribution. Rand_n, the docstrings are most probably the same. Okay, here if you want to see the description, return a sample from standard normal distribution. Okay, so it is going to use normal distribution. Okay, if you don't know what is standard distribution, please search it. I'm not gonna elaborate it too much, but it uses something called mean and something called standard deviation. Okay, and it gives you an answer according to that, and it will be minus and plus. You will have minus values and plus values. Let me just give you just a basic idea what standard deviation means. The standard deviation graph is something like this. It is called a bell-shaped graph, and the 0 is here. Okay, and you have 3 portion. Okay, and in this you have something called mu, that is mean, and this is called sigma, that is the standard deviation. The more you deviate, the further you go in the graph. Okay, the more you deviate, the further you go in the graph, and the more central you stay, the more possibility you have, the better data you have. Everything about you is positive. The more you deviate, the more left or right you go, you are going away from the standard. This is basically standard deviation in a broader term. Okay, okay, fine, let's create it. It is taking a shape, so let's input a shape and print it. Yeah, as you can see, there's minus and plus values, negative and positive values. It is decided based on the mean and standard deviation and standard distribution, as I have mentioned. Okay, fine. What else do you have? Another function that we can use to create numpy array is called rand_int. So from the name you can see it will be giving us integer values. Let's see their docstring. Yeah, you have to mention the low number and the high number and the size. If you want, you can also put in the data types. Let's see, we are going to have from 1 to 10, and we're going to have um, a shape. Here it will be third bracket. Mind it, guys, mind it. Many make mistakes. Okay, mind it. We're going to have a 3 by 3 matrix. That's it. So all the entries should have values from 1 to 10, all in integers, and it should be a 3 by 3 matrix. Let's see. And here you go. If you refresh it, rerun it, every time it will be giving you new values. Okay, here we have mentioned from 10, you can mention anything. Let's say 100, it will print from 1 to 100. Even if you want, let's say it is minus 10, you will be seeing now negative values also. So I hope you are clear. Okay, so these are the ways you can create numpy arrays. We have seen some functions earlier, these ones, and we also saw these ones using the random module, how you can create numpy arrays. So this is the first thing. Now how we can manipulate a numpy array, we're gonna go towards that. First of all, in the agenda we have attributes and methods. What are attributes? What are methods? Attributes, you know, the characteristics of a data that tells about the data or array in this case, what is in it, how many rows are there, how many columns are there. Okay, and the methods that we used earlier, the functions. Methods are called functions, or functions are called methods. It is the alternative names. We already used methods, so we don't need to elaborate this. We also used attributes, but let me show this again to you. We have created an array previously, and this is it, as you can see. If we want to know the shape, dot shape. If you want to know the dimension, and dim. Clear? Okay, if you want to know the data type, dtype dot dtype integer 32. Now if you want to reshape it, there's a catch. It is not an attribute, it's a method, and you can also see the doc string here. For reshape you have to mention the shape. Okay, now there's a bit of theory here. Let me clear it for you. Suppose our matrix is 3 by 4. Okay, so you can create only a certain number of reshaped arrays. And how do you define this? 3 by 4 means 12. So every number that multiplies into 12 you can create. What do I mean? You can create a 1 by 12 array, since it equals 12. You can create a 4 by 3 array, since it results in 12. You can create a 12 by 1 array, it is also 12. You can create a 2 by 6, it is also 12. So these are the options. Okay, I hope I'm clear. So what will be in our case? In our case the matrix is 3 by 3, that equals to 9. So here we only have two options. 1 by 9 equals 9, and 9 by 1 equals 9. Other than that we can't do anything else. So let's create. So let's mention 1 by 9, and let's see our reshaped array. Okay, something's okay. I think I have mistake something. Mm, 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 mm. Okay, let me remove the brackets and let's see if that works. Sometimes you have to do a bit of It's still not printing. Okay, let us see a bit what we can do. Is our array correct? Yes, it is correct. Array dot reshape into and shape of 1 comma 9. Okay, there's something wrong, I guess. uh, let's take this let us take this and let's print something new. Let's print something new. Array equals np dot array. Let us increase the digits. 1 comma 1 comma 1. Let's see the array. You can see it is a 3 by 4 matrix. Should we be able to reshape it? We should, right? We should. Let's reshape it. So 3 by 4 means 12. So we can create anything that multiplies into 12. 6 by 2, that multiplies, right? Let's see. And oh, you know what I have mistake? It returns the value. It returns the value. If you print it now, boom, it's a 6 by 2. We were printing the exact array here. Okay, we were not, since it returned, it is not stored, or it is not uh, replacing the array permanently. It is returning. That's why we are not getting the printed value. If we do something here, array 1, and print here, you will see. Okay, wait, we haven't created the array. Okay, oh, 129. Okay, let's see if we can solve this one. Let not. Okay, fine. Oh, we have adjusted. We have created a new array that is of 3 by 4 dimension. That's why we have to create or reshape something which multiplies it into 12. So we have created 6 by 2. We can also have what else? 4 by 3. We can have 1 by 12. We can have 12 by 1. So basically it should print something for which the dimensions multiply into 12. Clear? I hope I am clear in this one. Okay, so we are done with the array attributes and methods. The next thing is the indexing and selection. Indexing and selection. Okay, so we have seen selection. Let's first see the selection. Okay, we have seen selection in Python. How do you do that? Let's assume this is a list 1 2 3 4 5. I want to select the index called 0. Can we see that? Yes, we can, and it is returning the 0. If you have forgotten, let me really give you a quick reminder. 1 2 3 4 5. This is the value, and the index in the Python list starts from 0. So the index is 0 1 2 3 4. The 4 index is 5. The third 3 index is 4, and the 0 index is 1. Be very careful about it. It is basic Python, but most of us make mistakes in this. Okay, fine. Similarly, you can do this kind of selection using Numpy array as well. First of all, let's see our array that we have created a bit earlier. It is a 3 by 4. So let's say we want to select an item. Let's say this 72. So what is the position of 72? It is in the uh, one indexed row and one indexed column. Again, it is in the one indexed, index number one row and index number one column. Let's see. 1 comma 1 72. If you still didn't get it, let me clear it out. You have 0 1 2 3. You have 0 1 2 3. These are the rows and these are the columns, right? All the intersections, these are the entries. So our 72 was here. So can you guess what is the position? It is in the row number 1 here, and it is in the column number 1 here. Got it? Okay, fine. Can we index anything else? Let's see the array first. Let's say this one. What should be the selecting entry number? What is its position? Can you guess? Let's see. It is as I can see, it is the second row and the 0 1 2 second column. Fine. So this is the selection or selecting of Numpy array. Another thing, that is indexing or slicing. Can you do slicing? This is the Python list as we have created a bit earlier. How do you slice? Like this. We want to slice from 0 to the index number 4. So it will be printing from 0 to index number 3. Again, very careful. It will be excluding the endpoint. It is Python basics. Okay. Boom. See, this is called slicing. You can do the same thing in Python, Numpy array. Okay, let's see the array first. Let's slice it here. So before that, there's a bit of theory. The theory is array that you are gonna slice is gonna be row comma column. If you have depth, then the depth would be here. Since in this example we don't have depth, we are not gonna have this. So we have only row and column. But you have to mention the range separately for row and separately for column. So what I'm trying to say is this. You're gonna have to do starting row, start row, end row. Okay, you have to mention the starting and finishing of row as well as start column to end column. Clear? I hope I'm clear. Okay, fine. Let's see it in action. So we're gonna be slicing from 0 row to, we have 3 rows. Let's say 0 1 2. Let's take the first 2 rows. Okay, and we're gonna take from 1 to, let's say, 4. What is it gonna print? Let's see. Boom. It has taken from 0 to 2 rows. So this is the row number 0, this is the row number 1. It is excluding number 2. we are not going to get this one. Okay, we're not gonna get this. It is going to be excluded. Python guys, Python. So we have this row. For the column, we have column 1 to 4. The column 1 is this, 2 is this, 3 is this. We are not gonna have 4. So this is excluded. We are gonna have up until 3. That is why we are having this portion. Clear? Okay. Now you might be wondering, can we do the same thing for depth? Yes, we can. Let's go to our 3D array. Here somewhere we have created a 3D array here. So can we slice this one? Let's slice this one. Let's run it so that our array is up to date. Okay, array. First of all, as I said, you have to mention the depth. And since there's only 2 depth, okay, so the index value are gonna be 0 and 1. Mind it, guys. Very careful. 0 and 1. So we can either pick the first layer 0 or the second layer that is 1. Let's pick 1. 1. Suppose we are not gonna range anything. We are only gonna range in columns from 0 column to 2, sorry, row, and let's say 1 2 3. It should print. Yeah, got it. I hope it is clear. I haven't done any ranging here in the depth part, but if you have multiple and many dimensions or depths, then you can also do the ranging here too. I hope I am clear in indexing, slicing, selecting. Indexing and selection. Now, another thing that is booleans. So this is nothing. You can place any conditions like give me anything that is above 10. Okay, let us first print the array, otherwise we are not gonna get the exact value. Where is it here? Wait a bit. Okay, it doesn't matter. Let's have this one. Let's have this array. So we need every value that is less than 2, less than 3. You see, true, false, true, false, true, false. It is giving us the boolean values, fulfilling the condition. Really easy, and you get what I'm saying. So I hope you are clear on this one. So the next thing we're going to discuss is broadcasting. What is broadcasting? I have mentioned earlier that you can't do broadcasting in Python, but you can do broadcasting in Numpy array. What does this mean? Well, broadcasting means, suppose this is a Python list 1 2 3 4. Now if you are to uh, suppose add number 5, can you do this with this command? No, we have to run a for loop for each and every element and add 5. But in Numpy array you can do the same thing with this command and it will work. This is called broadcasting. You can do a command for every element in the array, whereas you can't do this for list. Okay, let me show you. Suppose we have a 1 2 3 4 5. We want to let's say add 5. It is giving me an error because can only concatenate list, not integer. It basically means it can't do this command, can't change every value at one time, at one go. Okay, but if you are to do the same thing in Numpy array, it worked. See this? This is called broadcasting. You can't work as a whole in Python list, but you can work as a whole in NumPy array. You can do plus, you can do multiplications, it will work. Anything you can do, say subtraction, it will gonna work. Everything. Another thing, another broadcasting is that you can change values. Suppose in Python you can't change a range. You can change, suppose I want to change 0 index to 5. It worked. If you see the A here, the 0 index is now 5. But if you want to range it from 404, it is giving me an error because it can't handle multiple elements at one time. But in NumPy, it can. If you do it in NumPy, in our array we have depth. So what can we do? Can mention the depth one, and the row number is also gonna be, suppose, 1. Let's see the array. First of all, let's print the original array so you can compare. This is the original array, and this portion is going to be 5. Let's see this. Yes, this is broadcasting in NumPy array, and you can do this in NumPy, but you can't do this in Python. Clear? Okay, fine. So this was broadcasting. Finally, we have numeric operations. You can do operations like you can do plus, minus, everything in NumPy array, as I have shown you now. You can do plus, minus, you can do array plus array. Let us create an array. Okay, let us create an array. Np dot array, or let us create an array using linspace that we have discussed earlier. It's going to be from 1 to 10, and the shape is going to be a 3 by 3. Let's see this one. What's the tuple? Let's see the docstring. Okay, it's not linspace. Sorry, my bad. It's not linspace. It is a range, if I'm not wrong. Let's see the docstring now. Step, it is not arranged. Then what is it? What is it? What is it? Let us go up and see it. Is it it should be linspace, right? Oh no, it's not linspace. It's not linspace. Okay, fine. Let us create it manually. Let's not go bother into it. Let's use, okay, let us use rendint. Rendint, what does rendint? Oh, random module dot rendint, and it printed. Okay, it is rendint, my bad, it is rendint. So this is our array number 1. Let's copy the code and have our array number 2, and let's name it array 2, and let's say we're gonna have from 11 to 20. Array 2. So these are our 2 arrays. So as I mentioned, we can do any mathematical work. So let's say array 1 plus array 2, it printed. We can do multiplications even, it printed. But the rule or the condition here is the dimension. Sorry, the shape must be same. If our array 2 is not equally shaped as our array 1, then it will give us error. Really be careful in this one. Fine. Okay, so the last thing that we have for our session is the functions. It is also very easy, really simple. You just write np dot any function that you want, let's say sine function, and mention the array, here array 1, and print. It automatically applies sine. You can do anything else that you like, let's say log. You can do exponential, anything that you like. So yeah guys, this was our session. So let us give you a summary what we have discussed for today. Okay, let us give you a summary here. So we have discussed about what is numpy. Let's zoom out a little bit. What is numpy, why is numpy, then we have discussed list versus array. Okay, then we have seen in the notebook, what have we seen? Creating array, we have seen selecting, we have seen indexing, we have seen slicing. Okay, we have also seen what mm, uh, what they say, some random modules, right, in creating part. We have also covered functions, log, sine, etc. We have also covered like the maths, the plus, minus, everything that you can do with numpy array. We have also discussed some of the attributes like endim, shape, etc. So this was overall for today's session. Before ending it, just want to mention another thing, that is documentation. Always you can look up to documentation if you get stuck. It is simply just search numpy and you will get here. There's API reference for everything that I have said, and everything that is all about numpy. You can find it here. So guys, this was about numpy. Later on, we are gonna discuss the other tools, the other libraries of pandas in using or learning machine learning that you can see. We are gonna learn pandas and other lots of libraries for our machine learning. So stay tuned, stay present in other sessions, and yeah, bye bye. Thank you all.